Lesson 5-1, solving polynomial equations by graphing. A related function is found by rewriting the equation with 0 on one side and then replacing 0 with f of x. The values of x for which f of x equaling 0 are the real zeros of the function. Those are also known as the x-intercepts or the roots of the graph. So in this example there, x cubed plus 2x squared minus 4x equaling x plus 6. The solutions are -3, -1, and 2. Those are also named as the roots. So what they did first was they got everything to one side and then made it equal to 0. So then you end up with a polynomial function of x cubed plus 2x squared minus 5x minus 6. Make that equal to 0. You can see the function there. You can see they cross in these exact locations. We're going to graph some of these and put them on our calculator to graph them so it'd be easier to find the zeros. For our first example, use a graphing calculator to solve x to the 4th plus 3x squared minus 5 equaling -4x cubed by graphing. The first thing I want to do is just get everything to one side. I'm going to add 4x cubed to both sides. And now I have a function of x to the 4th plus 4x cubed plus 3x squared minus 5 equaling 0. So we're going to grab our calculator. I'm going to go to y equals. I'm going to turn my plot 1 off. So make sure if you have that on, make sure the plot turns off. Then clear everything. Now I'm going to type in my equation, which is x to the 4th plus 4x cubed plus 3x squared minus 5. Then I'm going to hit graph. I'm going to have to change my zoom to standard. So you can see that it crosses in two places here, one here and one's here. So if I hit second, trace, I want to find the 0, number 2. And I go to the other side here. Left bound means it's above the x-axis on this side, so hit enter, go below, hit enter again, hit enter a third time, and I would get roughly -3.2. So we'll just round it to the nearest tenth. We could also do it to the nearest hundredth as well, but let's just do to the nearest. Yeah, we'll do it to the nearest hundredth. That'll make it a little more accurate. So x would equal roughly a -3.22. And then to find the other one, we hit second, trace, number 2, the 0. Now we got to go to the other side. Left bound this time is going to be underneath the x-axis. Hit enter, go above, hit enter a third time, and we get 0.84. So these would be our solutions to that polynomial function. Next, use the graphing calculator to solve this one. Again, I'm just going to make it equal to 0 by subtracting 1. So now I have -2x to the 5th plus x to the 4th plus 4x cubed minus 1 equaling 0. Grab our calculator again. So we have -2x to the 5th plus x to the 4th plus 4x cubed minus 1. Hit graph. Okay, so it crosses in 3 places. That tells us we need 3 zeros. So second, trace, Number 2, going to go to the left side. So left bound means above the x-axis. So enter, right bound below the x-axis. Enter, enter again. We end up with negative 1.27. That's one of them. Find the other one. Second trace. Number 2, the intersect. Left bound is now underneath. Right bound is above. Enter, and we get 0.64. And find the next one. Second trace. Number 2. Left bound would be above the x-axis now. Enter, go below. Enter, enter a third time, and we get 1.65. So those are our 3 zeros for this particular question. Next, use the graphing calculator to solve this one. This is round to the nearest hundredth if necessary. So I'm going to move everything to the other side. So I would have negative 1/2 x to the 4th plus 4x squared plus 1x minus 1. This is going to equal 0. So I'll grab our calculator. So a negative, I'm going to put a decimal 0.5 x to the 4th plus 4x squared plus x minus 1. Okay, graph. Actually, I need to get, yeah, that's correct. So graph that. So now we have 4 zeros, 1, 2, 3, and 4. So we need 4 answers. Second trace. Number 2. Left bound would be below the x-axis here. Enter, go above for the right. Enter, enter a third time. So we got negative 2.64. Next one, second trace, number 2. Now left bound is above the x-axis. Right bound is below. Enter, enter again, and we get negative 0.66. And find the next one, second trace. Here, need to go below the x-axis. Enter, go above. Enter, enter again, and we get 0.39. And our last one, second trace, number 2. Left bound is above. Hit enter. Right bound is below. Hit enter. Hit enter a third time, and we get 2.91. Those are our zeros for that particular question. Moving on to example 2. These are all word problems. It says, for an exhibit with 6 or fewer emperor penguins, the pool must have a depth of at least 4 feet and a volume of at least 1,620 gallons, or about 217 cubic feet per bird. If the zoo has 5 emperor penguins, what should the dimensions of the pool shown at the right be to meet the minimum requirements? There are 3 parts to this. Part A is write a polynomial equation. Part B, we're going to write and solve the system of equations. And part C, we're going to find the dimensions. So the first thing we're going to do is we're going to come up with the equation. So the first off, they tell us 217 cubic feet per bird. since there are 5 birds, I'm going to take 217 times 5, and that's going to give us 1,085. So we need 1,085 cubic feet to fill the pool up. So our dimensions of our current one is 2x times 2x plus 3 times 5x minus 2. So to find volume, you just length times width times height. So if I distribute here, this gives me 4x squared plus 6x, and then I'm going to multiply that by 5x minus 2. And this is going to give us 20x cubed minus 8x squared plus 30x squared minus 12x. Add straight down, I get 20x cubed plus 22x squared minus 12x. And this has to equal an area of 1,085. Now that these are my equations, so this is one equation, this is the other side of the equation. We're now going to use that to find the dimensions of the pool. So we're going to take our calculator, go to our y equals, this first one, this would be 20x cubed plus 22x squared minus 12x, and then the other one is just 1,085. Now my windows, I'm only going to be dealing with positive numbers, so 0, the x maximum, we can try to keep that at 10 for right now. The minimum, 0, the maximum, but I have to get at least to 10,085, so let's just do, I'll just do 2,500. We're going to count these by 200. Actually, let's count those by 250. And if I graph, here is one of our polynomial, here is their other one. So we need to find out where do they intersect. So if I hit second, trace, number 5, hit enter 3 times, this is going to tell us 3.5. So x has to be 3.5. That's the bare minimum because it has to be at least 417 or at least 1,085 cubic feet. So if x is 3.5, I can now solve to find the dimensions. So I have 2 times 3.5, which will give us 7 feet. And then I have 2 times 3.5 plus 3, so that's 7 plus 3, so that's 10 feet. And then I have 5 times 3.5 minus 2, and 5 times 3.5 is 17.5 minus 2 gives us 15.5 feet. And if you were to multiply all of those, that would give us 1,085 cubic feet. And our last question. The university wants to build a new residence hall with dorm rooms according to the diagram shown. If the university wants each room to have 195 square feet of living space, what should the dimensions of each room be? So here you have one room. You need to find the area. So this would be x squared minus 1, and we have to multiply that by 3x plus 1, and this has to give us 195 square feet. So if I distribute, this is 3x cubed plus x squared minus 3x minus 1 equals 195. Plug that into our calculator. We'll grab our calculator here. Y equals, clear this. Actually, let's make that a 3x cubed So this is plus x squared minus 3x and then minus 1. And this has to be 195. So the Windows setting, let's make the y maximum, let's make that 250. We'll count by 50s. Everything else should stay the same. Hit graph. Here's 1. Let's see, the y equals, I had the wrong number here. So now let's hit graph. Here's the polynomial. Here's the linear. You need to find out this part. So second trace, number 5, intersect. Hit enter 3 times. That tells us x is 4. So x is 4. I just need to do 4 squared minus 1 and 3 times 4 plus 1. 16 minus 1 is 15. 12 plus 1 is 13. So it should be a 15 by 13 room. So we'll make this feet. And if you want to check it, 15 times 13 does give us 195. So they want to have exactly 195 square feet. So that is our lesson on solving polynomial equations by graphing.